Okay, folks, so time to start stoichiometry. Today we're going to be talking about molar ratios. But before we move into molar ratios, I want to show you a couple things that I want you to do for me, okay? And look, I know that we're doing things a little bit differently. I know we're doing things. It's going to be a little more complicated, but I'm going to walk you through it. I'm going to help you, and I'm here to make sure that you understand this information. So this is your packet, and I have packets over here copied for you, and they were ready to go for Thursday. So we're going to have a packet pickup next week on Tuesday. So if you need a packet, you can come and pick it up. Anything that's in this packet, though, is in the Google Classroom. So you have access to it, but I just know some of us like to have this paper copy of this. So today, first off, one of your assignments is you'll see on the back a word search. This just kind of goes through some of the stuff that you're going to see, and I just said it was an easy little grade. So this is page 2 in your packet. But today we're going to be looking at this, okay? We're going to be talking about mole ratios. We're going to take a few notes. We're going to practice a few problems, and then your assignment is to complete page 3, and then you're going to complete page 4. Looks like this, and the back of it, page 5. Okay, so you're going to complete those, and the way that we're going to do this is you are going to take a picture of your work and you're going to send it to me. So answers just won't cut it. You got to send me your work too, okay? And then what I'll do is I'll have a video later that will show me working out some of the problems, and I'll have answers for you so that if you have questions, we can meet and we can go over that information. So we're going to start today, and we're going to be looking at this equation right here. So let me go write this equation down on my paper over here. So it's a synthesis equation. We're taking nitrogen and we're adding in hydrogen, and we're making ammonia. And it's balanced for us, and we know that because it's got coefficients right there. So today we're going to be focusing on these coefficients. Okay, so we know we have 2 moles of the ammonia. We know we have 3 moles of hydrogen because this 3 tells us that. And then right here where the N2 is, we've talked about in class how this is an understood 1. We don't write that 1, but you and I both know that that blank means that there's a 1 there. So basically what this tells us that every 1 mole of nitrogen, I need 3 moles of hydrogen to produce 2 moles of ammonia. So what ends up happening is I can create what's known as a molar ratio. A molar ratio just tells me how many of each one of these, how many moles of each one of these I need in order to accomplish this reaction. So right here in your worksheet 1A, they want us to write the molar ratio of N2 to H2. So what I'm going to do is I'm just going to look right here. N2 is 1 mole of N2. And then how many moles of H2 do I have? 3 moles of H2. So this is what we call our molar ratio, okay? And I can write this as 1 mole of N2 over 3 moles of H2, or I could write it as 3 moles of H2 over 1 mole of N2. So I can flip it if need be. It doesn't change this relationship, but it allows me to manipulate this ratio. So let's look at the next one they ask us for 1B. It's N2 to ammonia. So let's look at N2. It's 1 mole of N2. And how many moles of ammonia? 2 moles of ammonia. So now I have a molar ratio, and I can also write it as 2 moles of ammonia over 1 mole of N2. Same thing. Last one that they give us, H2NH3. So once again, we just look at our coefficients. We have 3 moles of H2 to 2 moles of ammonia. And then I can flip-flop it to 2 moles of ammonia, 3 moles of H2. So just by looking at this equation right here, I'm able to come up with 3 mole-to-mole ratios or molar ratios, and then I have the ability to flip them around as need be, okay? So what I want you to do is I want you to pause the video when I count down, and I want you to work through number 2, and we'll see how you do, okay? So 3, 2, 1, pause. Okay, so let's look at that number 2. For number 2, they give us 8H2 plus S8 yields 8H2S. So for 8, the mole ratio of H2 to H2S would be 8 moles of H2 to 8 moles of H2S. Then for B, it was H2S8. So this would be 8 moles of H2 to 1 mole of S8. And then C is H2S to S8. So that would be 8 moles of H2S and 1 mole of S8. So there's our mole to mole ratios for number 2. Okay? So let's go on and look at how we can use this, because what ends up happening is we can use these mole ratios as a conversion factor, and we can convert throughout a reaction. So let's look at number 3. So number 3, they give us 2H2 plus O2 yields 2H2O. And for part A, they want to know what is the hydrogen to water mole ratio. So I'm going to write that as 2 moles of H2 over 2 moles of H2O, because I just look at my coefficients and get those numbers. So let's go on to B. So B tells us, suppose you had 20 moles of hydrogen on hand and plenty of oxygen. How many moles of water could you make? So what we're going to do now is we're going to go up here to our formula, our equation, and we're going to look at what they're giving us. So right here, they tell us that we have 20 moles of H2. So right above my H2, I'm going to write 20 moles. And then they want to know how many moles of water could you make? So question mark moles. So this gives us a given, and this gives us an unknown. So if we know that we have 20 moles of hydrogen, and I know that there is a connection through the mole ratio of hydrogen to water, I can figure out how many moles of water I would make. So what we do is we do what's called a mole-to-mole problem. And that's what we're going to be learning how to do today. A mole-to-mole conversion problem. So let me write that down again. We have 2H2 plus O2 yields 2H2O. And they told us that we have 20 moles of hydrogen, and they need to know how many moles of water. So we're going to start with our given. So down here, I'm going to write 20 moles of hydrogen. And now I need to bridge the gap between hydrogen to water. And the way that I do that is my mole to mole ratio. So I need to put my moles of hydrogen on the bottom so that I get rid of these moles of hydrogen. So I'm going to put 2 moles of hydrogen on bottom, and that's going to put my 2 moles of water on top. So now I can cancel out moles of hydrogen, and I'm left with moles of water. And so that's what we were looking for. So now I can just work it out in my calculator. So I'm going to say 20 times 2 divided by 2, and that gives me 20 moles of water. 1 sig fig, 1 sig fig. So that's my answer. Okay? So this is a mole-to-mole conversion problem. If they give you the given in moles and your unknown is in moles, you just simply use your given and the mole-to-mole ratio and work it out. So let's go on and look at C. For C, they want to know what is the oxygen-water mole ratio. So I have 1 mole of oxygen, and I have 2 moles of water. All right? So now we look at part D. Part D says, now suppose, I'm going to rewrite the reaction. So now it says, suppose you had 20 moles of O2. So I'm going to write that right here. And enough hydrogen. How many moles of water can you make? So once again, I'm going to start with my given. And I need to use this mole ratio. So if I want to get rid of moles and get water, I need to put moles of oxygen on the top or the bottom? On the bottom. So now I cancel out my moles of oxygen, and then I'm going to work my problem. 20 times 2 divided by 1 gives me 40 moles of water. 1 sig fig, 1 sig fig, and there's my answer. Pretty easy, huh? Okay, so what I want you to do is, in just a second, I'm going to have you pause this video, and I want you to go on to number 4 at the bottom of page 3. And I want you to work out number 4, A through D, and then hit play again, and you can watch me work them out, okay? So in 3, 2, 1, pause. So our equation is N2 plus 3H2 yields 2NH3. And so for part A, it says if you use 1 mole of N2, how many moles of NH3 can be produced? So I start with my given, 1 mole of N2, and then I do my mole ratio. So 1 mole of N2 on bottom and 2 moles of NH3 on top. Moles cancel out. And then I run it through my calculator and I get 2 moles NH3. 1 sig fig, 1 sig fig, so there's my answer. For part B, same reaction. They say if 10 moles of NH3 were produced, how many moles of N2 would be required? So start with my given. I'm going to put my mole ratio 2 to 1, 2 moles of NH3 on bottom, and my 1 mole of N2 on top. Run it through my calculator. 10 times 1 is 10. Divided by 2 is 5 moles of N2. Then we go to C. Same reaction. This time they tell us 3.00 moles of hydrogen were used. How many moles of ammonia? So we start with 3.00 moles of H2. Mole to mole ratio, 3 moles of H2 on bottom and 2 moles of NH3 on top. So 3 times 2 is 6, divided by 3 gives you 2. And how many sig figs? 1, 2, and sandwich 3. So I have 3 sig figs. All right, and there's my answer. And then moving on to D, same reaction. This time we have 0.600 moles, and they want to know how many moles of hydrogen. So 0.600 moles of ammonia, 2 moles of ammonia on bottom, and 3 moles of hydrogen on top. So 0.6 times 3 divided by 2 is 0.9, and this is 1, 2, 3 significant figures. So I have to add those zeros, because remember, final 0 is significant, the 9 is significant, and this one's significant because it's sandwiched. Okay, so here are your answers for 4A through D. Now, if you noticed, as I was working these problems, every time I wrote out my reaction, every time I wrote out my known and my unknown, my given and my unknown, and every time I checked my sig figs and I circled my answers with the units, okay? You need to get in the habit of good steps when doing these problems, because they're going to get a little bit longer as we go. So get into the habit of having good habits in working problems, okay? So now that we've done these, your job is to go in and do pages 4 and 5, mole-to-mole problems on front and back. And then after you finish those, you'll take a picture of your work with your answers circled, and you will submit it to the Google Classroom. If you have any questions, please feel free to shoot me a message via email or Remind, and I'll be glad to help you in any way I can. Talk to you later.